So, it's time we start moving on now to look at some bits of probability that are quite crucial. Consider a scenario where you have a poor man who goes to work in the rain. Or perhaps he doesn't go to work in the rain. Then you've got a situation where you have the same man may be late for work, or he may be not late for work. Now, your first thought is to go, well, hang on a second. Based on part 6, before I do any calculations, I'll need to have checked whether these two events are independent or not. And that's very astute if you've realised that process is essential here. Now, we don't know for sure is the actual answer, so we're going to have to carry on and hope that they are. But what we do have is a lot of probabilities to work with. And because we've been provided a huge amount of information, we should be okay to work on this anyway. So, let's take a look at this situation. Now, it could rain or it could not rain. He could be late or not late. So we've got some options to consider here. Now, if I was to draw a diagram like this, you might say that's a possibility space diagram with rain and not rain and late and not late. And you'd be right. Is there a different way of showing it that could help us later? Well, we're going to use a probability tree now. So, first off, imagine there's just the weather to consider. Now, there are two different universes that can exist. There's the universe where the man goes to work and there's not rain. And then there's the universe where the man goes to work and hopefully he has his umbrella, because you know what? It's going to rain a lot. So, those two parallel universes exist at the same time. The one where there is no rain and the one where there is rain. And here will be the moment that we find out whether the rain happens that day or not. Now, the thing about parallel universes is they get quite confusing, because there's a universe now where there's no rain, but then other things happen to the man. So, for example, he may arrive for work just before 9 o'clock. So he may not be late, but also he might arrive just after 9 and he may be late. And both of those events are possible. But no matter what happens with the weather, he's going to work. So he could be not late for work in the rain, or in the rain he could be late for work. Now, these are very simple parallel worlds where only two decisions happen. But you can see here we've got no rain, not late. No rain, late. Rain, not late. And rain and late. So this probability tree diagram looks exactly the same as our possibility space diagram from previous. Now, you might say, what's the purpose of using this diagram rather than that diagram? Well, the best use of this diagram comes in doing calculations. And actually having two different options, as well as just calculating manually, gives us a real advantage. Remember that when we looked at possibility space diagrams back in part 4, we found that they were sometimes really helpful for working out questions that perhaps our obvious common sense brain would get wrong. So, a different way of showing the diagram. That's helpful. Okay, how can we develop this idea further then? So, here's another probability tree where a team, let's say this is Liverpool, because you know I always use Liverpool, play 2 matches. So they win or they lose, probably win, then they win or they lose. Now this diagram is actually flawed. What's wrong with it that makes it not accurate for a situation? Well, I'm impressed if you said, but hang on a second, there are 3 options in a football match. Why does your diagram only have 2? Well, a probability tree isn't limited to just 2 options. We can have a 3rd option, so let's draw it on. So here it is down the middle, it's draw. Here it is down the middle in the 2nd match. And from a draw, you could win, lose or draw. You could also have a 3rd match that follows. And you can see very quickly that sometimes your tree might get really quite big. Why use these then? Well, 1, 2, 3 or more events. Take a look at our possibility space diagram. 1 event, 2 events. Where would you put a 3rd event? Well, the answer is actually, you can't. You've used your 2 dimensions that are available, and now you're limited in terms of where you can go. So if you have more than 2 events, your probability tree is essential. Let's look at a situation here where you have to be careful with your probability tree. And this is a driving test. So, I do a first driving test and there are 2 options, a pass or a fail. Hopefully, I'm very happy because I've passed. Hopefully I haven't failed. But remember, life is full of failures. In fact, failure is very common. Now, what happens on my 2nd test? So think of this as different lives. What happens if I fail my test? Well, the 2nd time I do my test, I could pass it, phew, or I could fail again. What happens if I pass the 1st time? Some people will rush to draw this. If you pass your driving test, do you have to sit another test? No, you don't. So this part of the tree, this different alternatives don't exist. Once you pass, you are done. But the fail branch would carry on. If I make them smaller to show you, you could have Lots and lots of those. So this is a way of showing how probability works. And in the next part, we're going to start to look at calculations involving it and how we can use those.